What is light? Is it a particle? Is it a wave? Is it both? Is it neither? Physicists had the same question in the beginning of the 20th century. Before we answer those questions, let's look at what made them ask those questions. In an experiment that was done in the 1900s, it was found that when ultraviolet light was shined on an aluminum plate, the electrons in the aluminum plate left their respective atoms. After more experiments, it was found that the theory that said that light traveled in particles explained this. Let's use an analogy now. You are hungry and want some apples. You see an apple tree, but you can't reach any of the apples on the apple tree. So you pick up rocks, aim at the apples, and then throw them one at a time, but only at one speed. Let's say 2 meters per second for now. It's very important that you throw only at one speed. You miss multiple times, but you finally hit an apple. But the apple doesn't fall because the rock you threw didn't give it enough energy to detach itself from the tree. You take another rock and throw it at the same speed. This one's heavier though. The rock has more energy this time, and when the collision occurs, comparatively more energy is transferred to the apple. This energy was enough to detach the apple from its tree. The theory was a lot similar to this. The frequency of the light that traveled in as particles was like the mass of the rocks. Higher the frequency, higher the energy of the particle. When particles of light travel and hit an electron, they give up all of their energy to the electron. Depending on the amount of energy gained, like an apple from a tree, an electron leaves from the metal plate. Or it doesn't leave. But according to the theory, it does it a little bit differently. According to the Bohr model of the atom, there are distinct energy levels that electrons can be in. For example, helium atoms have 3 energy levels. In its case, if an electron is at the innermost energy level, it needs 23 electron volts to get to the outermost energy level, but still stay in the atom. Only if the light particle gives the electron more than 23 electron volts, the electron can leave the atom. Any energy level jump below that will be totally useless. This whole thing was called the photoelectric effect. It reinforced the assumption that light was a particle. And it couldn't be. Experiments like Young's double-slit experiment said that diffraction occurs with light. Diffraction is something that can happen only with a wave. Back to an analogy now. You behave like you equally like both dogs and cats. But if people were to ask you if you are a cat person or a dog person and expected one answer from you, you would be forced to give one answer to them. Light is something that travels both like a wave and a particle, but it's neither. Just like you can like both cats and dogs, but neither be a cat person nor a dog person. It's something that travels in wave packets of energy, also known as photons.